When a wave approaches some sort of boundary, it often has a transmitted portion and a reflected portion. We saw this when we looked at light in Snell's law. There was some refracted light that went through, but a lot of it was also reflected. So let's imagine a wave traveling toward a fixed point in the wall. So it's moving in this direction. Now, when that wave hits this fixed point, it actually flips over when it's reflected. So this represents a phase shift of pi, because what was a peak became a trough. Now, let's also imagine a wave moving toward a pole that has no fixed end and can instead adjust. So as it comes in to that pole, it'll actually be reflected with the same exact phase. So we get a phase shift or change in phi of 0. A similar idea actually happens when you move from one medium to another. When light travels from air to water, for example, a light medium to a heavy medium, we see an incoming wave go in and get reflected backwards or flipped so that it has a change in phi of pi. Now that only occurs when we went from light to heavy, as we saw with a wave moving into a fixed point. Now in the reverse, if we have a wave traveling in a heavy medium toward a light medium, when it's reflected, it will maintain its phase. So change in phi will equal 0. So what's the rule we're looking at here? Well, if we have more resistance where the light is going to be reflected or the wave is going to be reflected, for instance here, this is going to exert some kind of force as opposed to here, which is going to kind of be willy-nilly, or here where the water is a lot harder to travel through than the air, that's when we get a change in phi of pi. Now, if it's less resistant to the wave traveling, so if there's an end that's free or reflecting around air, in that case, you'll get change in phi of 0.